Cartoon Network presents Atoms, Elements and Compounds. So let's start off with the differences between these three things. An atom is the smallest unit of matter and it is made up of negative electrons, positive protons and neutral neutrons. The center of an atom is called the nucleus, and this is where you'll find protons, neutrons, and the electrons orbit around the nucleus. In an atom, the number of electrons is equal to the number of protons. So in a lithium atom, if it has 3 protons, then it will have 3 electrons. A compound is where 2 or more different atoms are joined together. So if we have oxygen and hydrogen, they form a bond. And this is water. And another compound you'll be familiar with is carbon dioxide. An element is a substance that is made up of only one type of atom. So if we take a piece of gold and take a close look, we know that it is made up of only gold atoms. But how do we know what atoms look like? Well, John Dalton was the first to propose what atoms look like, and he formed his Dalton's atomic theory in the 1980s. And he said that all objects are made up of tiny spheres called atoms. Atoms cannot be created or destroyed. The atoms of one element is different to another element, and in a chemical reaction, atoms are combined or rearranged to make new molecules. But some of Dalton's theories weren't all correct. For example, he said that water was OH, which we know is incorrect. Water is actually H2O. And also, he said that the atom was the smallest object. However, he wasn't aware of electrons, protons, and neutrons. So now that we know what atoms, elements, and compounds are and who thought of them, we can now use the periodic table. And here we'll find out about chemical symbols and formulae. So if we take a closer look at the periodic table and find out how it's written, we can find the atomic number, the name, the symbol, and atomic weight. And this is for the first element, hydrogen. And these chemical symbols have to follow rules. So H for hydrogen is in capital letters, and this is the same for carbon. And the first letter is uppercase and the second letter is lowercase. So in the case of magnesium, M is uppercase and G is lowercase. So it's not lowercase m and lowercase g, and it's not uppercase M and uppercase G. Let's take a quick quiz. You have 5 seconds to write down the symbols of these elements. Time's up! Let's check. Did you get these right? Magnesium is Mg, sodium is Na, and oxygen is O. So a chemical formula is used to represent an element or compound in balanced equations. But what does this all mean? Let's take a look. So in compounds, we use subscript to show that the atom appears more than once in a compound. So in the case of CO2, we know that there is 1 compound and 2 oxygens. Remember, it's subscript, not superscript. So it's not CO to the power of 2. So H2O and CO2 are compounds made of atoms, but they look and feel different. So why is that? That's because of the 3 states of matter, which are solids, liquids, and gas. Solids are particles bound tightly together to have a repeating pattern, and these have fixed volumes. Liquids are particles that take the shape of their containers. And gases are free particles with random movement, like oxygen and nitrogen. And you can easily transfer between these 3 states of solid, liquid, and gas. So let's take a look at the first one, the easiest, melting and freezing. Melting is where you heat up a solid, and this gives it kinetic energy, heat energy, and it makes the particles vibrate. And this causes some of the attractive forces to break, and it allows the solid to rearrange to form a liquid. Freezing is where you go from liquid to a solid, and particles have less kinetic energy, so the particles pack together and this forms a solid. Now let's look at condensation and vaporization. Vaporization is going from a liquid to a gas, and this is where you continuously heat a liquid and it gives it kinetic energy. And this is where the atoms at the surface break all bonds and it makes a gas. Condensation is where you cool down a gas and it reduces that heat energy. They slow down, they come into contact with one another and they form a bond. And this is where the gas turns into a liquid. Now let's take a look at deposition and sublimation. And not many chemicals are able to do this. However, solid carbon dioxide can undergo sublimation. So there you go, going from solid, liquid and gas. But why is this transfer between states of matter useful? Well, it shows that through bond breaking and bond forming, chemical reactions can happen. And these chemical reactions have to follow a law. And this law is called conservation of mass. And this says that mass cannot be created or destroyed in a reaction. So particles in a substance stay the same when changing states, and only their closeness and arrangement or motion change, like going from solids, liquid and gas. And also the masses must be equal on both sides. So if we have a reaction, the reactants, here we have 1 carbon, 4 hydrogen and 4 oxygen. If it goes through a reaction and forms the products, we'll have the same amount of atoms, so 1 carbon, 4 hydrogen and 4 oxygen. It's just rearranged differently.